going into the practice now of 6.3, as we look at it, I'm going to use the whiteboard, and there is example 1. And again, what's the strategy? Well, it's basically when you see something like this in its log form, convert it to its exponential form. So our base is 7. Our exponent is 2. And our answer is 2x minus 1. So pretty straightforward. This is 49 equals 2x minus 1. We're going to transpose the negative 1 over to the other side where it becomes a positive 1. And 49 is 50 equals 2x. Divide both sides by 2, so x here is 25. Okay. We'll move on to the next one. Now, in example 2, notice they've written it this way, and I've switched it around a little bit. That's okay. Let's go to the whiteboard. Here, they want us to go from exponential form into its logarithmic form. So, actually, we could just leave it here and do it. So we know we need log. So what's our base? 18. What's our answer? G. And what's our exponent? 6. And that's all they're looking for. So hopefully something easy. And this example, they want us to go from log form, and I've switched it around, to exponential form, and they do not want you to simplify your answer. So what's our base here? 33. What's our exponent? 2x. And what's our answer? 197. So again, just converting, and we're not simplifying. Now, for example 4, we're going to look at transitions here. And the protocol to follow is think of what would the graph look like if our base, instead of being 1/4, was 4. Well, remember, whole number graphs look like so. And that would be if it were a whole number. But how about if it was a fraction? Now, I'll put this in black. We said if it were a fraction, they're generally going to take this shape. Ended up with blue, actually, where it comes high and then goes down this way. Now, again, we're just giving some general models because the example you get will be different. Now, you're then going to choose from graphs, and I've only put parts of 2 of them. They give you 4 graphs to choose from. Now, since this is a fraction, and we know it's going to be the blue line, would you choose this one? And the answer would be no. Now, as you look at this, how about, are you interested in this one? Well, it has that basic shape, doesn't it? But notice there is no value out here which would cause a vertical shift that is up and down as this one indicates. So what are we looking for? Well, we said when it's inside the parenthesis like this, it's going to shift it horizontally, and it's the opposite sign. So it's going to shift it 4 units, which this one is indicating 4 units, but this was also horizontal. So we're going to look for a graph, and I'll just sketch that one here. I'm still using blue. That's going to take this line and shift it over 1, 2, 3, 4. So it's going to look like and this would be going through 5 here. This is getting close to 4, and something like so. So again, you're going to reflect. Does it start high and go down, or low and go up? These would be the whole numbers. These would be bases that are fractions. And then horizontally, if this is positive, you move it to the left. If this is negative, you move it to the right, that many units. And if you had a value here, like this, if this were a 4 here, plus 4, this one here might be in contention, where you're moving it up 1, 2, 3, 4. But again, you have to look at and make the proper selection. And the nice thing about using practice to do this, if you don't get it right the first time, you get a second choice and hone your skills. I'm going to give you a little bit more enrichment on graphing and transitions here. I've gone to a site, Mathway, which is like Desmos.com. This is another math program software that you can get online. I've selected in the program pre-calculus, which is what this is. And it allows you to do some free work. And if you wanted to buy the program, there's a monthly fee or a yearly fee, and it would show you in detail how to get something. But just to give an answer, what we're looking for, I'll give you the detail. I've typed in the example that we're working on, and I'm going to go over here to this little arrow and say, what do I want to do? Well, I want the graph of this. Now notice you can find all these things, the domain and range, the asymptote, whether the inverse, whether it has one, etc. But let's just do the graph. And here they're giving us some points to graph. And there is the graph. And we'll pause, and I'm going to put a few more things in there for vocabulary building. So with the value in the parentheses, this x minus 4, the horizontal shift is not negative 4 this way, but a positive 4, opposite sign this way. So our new vertical asymptote, where it was primarily before x equals 0, with the shift, the asymptote now is x equals 4, which is right there. And it goes through x, or I should say y being 0 here at x is 5. That is that horizontal shift, and there's the graph. Okay. I'm going to do a couple of these so to give you that background. As we look at example 5, and again, we're looking for strategy here. They're giving us an approximation of E, but we can find E in our calculator. And this is in its logarithmic form. If we want to convert it to exponential form, what is our base here? Well, our base is E, natural log base E. So E to the second power is going to equal this answer, and that's what I've done here. So let's go to the whiteboard. And what would you do? Well, you're going to get a value for E squared on your calculator. That will go there. We're going to then transpose this positive 4 over to this side where it becomes a negative 4. And that equals 4x. We're going to then divide both sides by 4. And that will be our value. Now I'll do that on my end. We'll go back to the regular board here, and we'll put our answer in and see what we get. Okay, so doing the math, I got this when I squared E. I didn't round off. I subtracted 4, so it would be 3 in all of this. Divided this by 4, and I got this to 3 decimal places, had more, but I looked at the third. I'm going to drop the 7 and make this 4, 5. So there is my answer to number 5 and the protocol to get to it. Now for example 6, recalling what we said, natural log base E of x equals 19.7. We said when something was in this arrangement and there was an E here, natural log base E of E, we take our exponent, put it out in front here, because this part just became a 1, so x is actually 19.7. So again, recognizing this form, again, that's the solution. For example 7, as we look at it, there is our logarithmic form. The strategy would be to convert it to its exponential form and solve for x. So on your own, take a moment to do it. Then I'll show you the example worked out. So 2 to the 4th equals 7x. 2 to the 4th is 16 equals 7x. Divide both sides by 7. X is 16/7. Again, having the strategy of doing it. So for example 8, again, we're going to convert this to its exponential form. So our base now is 1/28 to the 2/7 power, and that's going to equal x. So now all you have to do is put 1/28 into your calculator, raise it to the 2/7 power, and see what you get. Again, putting it into your calculator, 1/28 caret, you put 2/7 as a fraction in parentheses, and the answer is 4. So putting in its radical form, it's the 7th root of 128 is 2, and 2 to the second power is 4. All right, we're now going to go on to example, I'm calling it 10 here, but it probably should be number 9 here. Let's move it up. Now I'm back in Mathway. This was the example they gave us. And inspecting it, what do we expect in our graph? And they're going to give us 4 graphs to choose from. Well, we could kind of move this, I think, this one over here to its vertical shift, that we're going to move it up 1. Now, within the parenthesis here, x plus 2, we know we're going to shift it horizontally -2. So it's going to go to the left rather than to the right. But notice we have a negative log here. What will that negative log of base 1/4 do to our answer? So I have it in our Mathway. I typed it in. I'm going to use the free part of it. I'm going to go to this and say, what do they want us to do? We want to find the graph. So I click on that. Now they've given us some points, keeping in mind now that x is a -2. This is going to be our new asymptote. That is that shift, not to the right, but opposite sign, -2. But will the curve look like a 1/4? But it's a negative log, or does something happen? Let's look at the graph, which is right here. Click on the graph, and there it goes up. So what can we pick up? Well, again, that horizontal shift, because of the +2 in parentheses here, was actually a -2. So it moved it over to negative x is -2, which they're showing here as a dotted line. But the base, which originally is a fraction, which should have come like this, is in a sense reversed or flipped to become what would be its reciprocal of 1/4, 4. And that's what we're seeing here. Now I've sketched in, if this would have just been an x without the vertical shift here and the horizontal shift here, the black line would have looked like this. And now we're going to move it 2 units to the left here. So from our 0, it's over 1, 2, now goes there. That would be this one here. Then this one here, and then over 2 up 1 to get our new graph. Okay, again, a good tool to use, and hopefully you're catching on. All right, let's go on. We get this example, and I've just copied it big. We're going to go to Mathway to check it out and see what they give us. So I've put it in, and now we want to solve for x here. I'll click on this, solve for x. and it says that x equals 4. All right, keeping that in mind, it says tap to view the steps. So one of the methods for solving this is to graph them. So here we can think of this as y equals 36. And that's this horizontal line, y equals 36. And then graphing this side, it's a curve that goes up and intersects right there. If we were to make this bigger, this point of intersection is 4, 36. So our x value here is 4. Now, this is one way to think of it. Our textbook suggests another way, and that was to put each side into its log form. So log base 2 of x is equal to log base 6 of 36. Well, looking at this side, we get that our base is 6. To what power would that be needed to make it, what exponent to give this answer? Well, that would be 2. And I'm taking away this here. So we think of this as a 2 here. So if we put a 2, and I'll change colors, a 2 there, 2 to the second power is 4. Now, I'm not sure that's the way to solve it, but that is a way to get to the 4. Again, you may need more help on this. Give it your best shot. Let's go on. In our next example, we're going to take a look at this one. And it's without a use of a calculator to determine what this would be. So if we're going to convert this from its logarithmic form to its exponential form, our base is 1/3. X is the exponent, and it's going to equal the answer 9. Now, what form of an exponent here would make a fraction into a 9? Well, it has to be negative. And if you see 1/3, and you're brainstorming here to a -2, this becomes then 3/1 to a +2, which is 9. So our value here then is going to be -2. All right. In our last example, we have this to match up with graphs. And as we look at this, I put a couple of blank ones here so we could play around a little bit. So again, the protocol was just to do this one first without any transformation. And this is going to look like this. So what would be the transformation? Well, we're going to move it not horizontally now, but vertically up one. So instead of going through here, it will now go through there. Otherwise, very similar. And in a sense, that was an easy one. And while we're here, just to give a little more example, what would this one look like? Well, here we see it's a whole number greater than 1. So it's going to go through 0. It's going to go through, when 1 is 1, it'll go through 3 here. And then later 9. And 1/3. So it's going to have this shape, but going through those points. Now, suppose we put a +1 here. Well, that would just raise it up 1 here, raise it up 1 there, and the curve would go up a little higher. Again, this would be a vertical shift. Now, how about if you had something like, and I'll erase this, get my eraser going. X plus 2. Well, again, since now this is in parentheses, this is going to shift it to the left 2 units. So instead of going here, it would go over 2 units and would come up like so. All right, just to give you an idea, and again, you'll have your practice, and hopefully this was helpful. And since I have Mathway open, why don't we do just a few more? Because I think it's kind of cool. So again, brainstorming. Here we have a function, log base 5. Now, what are we going to do here? Well, again, we can get some points, but it's going to be transformed to a -2. So is that going to move it in the negative direction 2, that is to the left, or a positive direction 2 to the right? It's going to move it to the right. And our points will be like 1/5, 0, and 5. All right, let's check it out. Do the graph here. Graph. And graph. And there it goes. So notice our shift was not to -2, but the -2 in parentheses became a +2. So our new vertical asymptote is x equals 2. And then there's 1/5 over here, 0, and then 5. Again, moving it. So this is where the 5 would have been if it was over here, but it's 2 units from the 5, and then up 1. Okay, let's do one more. So here was one we did similar earlier, where it's 1, and then log. Now notice that the log is negative. So where this might have gone, if that was a positive log, whole numbers, would have looked like 1 here, 0, and then this would be 1/6 over there, and then it would go 6, something like that. Because it's a negative log, it's going to be the reciprocal of that, and it would be like 1/6. And again, shifting that 1/6 up 1 from where it is if it was just log of 1/6. So log of 1/6 would be like so, would be the mirror image of this. But now we're going to take this point and shift it up 1. Again, I like it perhaps over there. Show you that that's going to be a vertical shift. All right, let's clear this up and look at the answer. And there we see it. that instead of this point being there, it's moved vertically up one spot, and there is that. All right, well, this is long enough, perhaps. Some challenging material. Hopefully, again, it's helpful.